All right. Okay, so you always need to make sure you have a beaker. A lot of people are putting like a top on their beaker. Don't do that because beakers are open at the top, okay? So you got to have 2 beakers for a galvanic cell. You have to have the electrodes. Make sure you don't label it Au3+. It's always, the electrode itself is always the neutral metal. Sometimes people forget to put in the liquid. Make sure you have, it can be a straight line, but make sure you put in the liquid. And the other thing you need connecting the 2 beakers is, of course, the salt bridge. Salt bridge needs cotton in the ends. And the 2 electrodes need to be connected by a wire. And we will often put a voltmeter there. I know voltmeters should be connected in parallel, but you know, whatever. You can put a light bulb there, okay? Light bulb works fine. And then we make sure we have our ions. And if you're ever wondering who is the cathode and who is the anode, what you're going to do is you're going to make sure you go and you look at your data booklet. And you're going to say, either I'm going to start with the red circled ones, Au3+, and cobalt, or I'm going to start with the green circled ones, Au solid and cobalt. The spontaneous reaction is between Au3+ and cobalt neutral. So what that means is that our reaction is going to be between Au3+ and cobalt neutral. That means those are my reactants. And that means that in the gold half cell, the Au3+ has to be the reactant reacting with 3 electrons to give us gold. And in the cobalt half cell, there we go. So this one is gaining electrons. This one is losing electrons. And if we gain electrons, is that the anode or is that the cathode? And how do you remember? I'm going to give you a trick to remember, okay? Oxidation occurs at the anode. Those are both vowels. So oxidation occurs at the anode. Reduction occurs at the cathode. A and C are both consonants. Oh, sorry, R and C. R and C are consonants. Another way of remembering this, does anyone remember the one, the little memory device that Tyler taught you? Yeah, an, ox, paired, and ox paired. Oxidation occurs at the anode, reduction occurs at the cathode. Or you can do red cat. Yeah, an ox, red cat. Yeah, I forgot about that one. I think this one is Hebden. I think Hebden does an ox cared. Anywho, you've got both of those. If it is the case that oxidation occurs at the anode, that means that you can then label the cobalt the anode. Be careful not to just do this. Anode. Sometimes people try and label the entire half cell as the anode. The anode is literally the stick of metal, okay? So I would always make sure I had like a little arrow pointing from the word anode to the stick of metal. And then this would be our cathode. Again, pointing to the stick of metal. And because we have the anode losing electrons and the cathode is gaining electrons, which direction do electrons have to move? From the cathode to the anode or from the anode to the cathode? They have to move from the anode to the cathode. So the electrons have to move that direction. If you need a quick way to remember it, electrons move in alphabetical order from A to C, from anode to cathode. Now there's other things that are moving in this half cell. What else is moving in this electrochemical cell, this galvanic cell? What else is moving? Ions. And where are those ions moving? Mostly in the salt bridge. Okay, so we have, let's say I chose something. I might choose potassium. I could also choose sodium. The reason I might like to choose potassium is that potassium is very electrically non-reactive because it's got a potential of negative, the K plus ion has a potential of negative 2.93 in terms of reaction, so it's not very reactive, okay? I could choose, in terms of something that's electrically non-reactive for an anion, I could choose SO4 because if I go backwards, that voltage is negative 2.01 volts. However, occasionally you'll get sulfate precipitating with something, so you do have to watch out for that. So nitrate is also a good choice, okay? Unless you've got acid around, in which case it starts to become a problem, right? But if it's non-acidified, then you're okay. So just watch out for those little details. Okay. So we have our K plus, maybe we have some NO3 minus. Ooh, I forgot to put my cobalt ions in here and my nitrate ions. One thing that you can do is you can show the ions in solution either jumping onto the electrode or coming off of the electrode. So at the cathode, our half reaction is Au3 plus 3 electrons gives Au, which means that Au is moving on to the cathode and turning into Au solid. Yes? The cobalt, our cobalt half reaction is CO goes to CO2 plus 2 electrons, which means that the cobalt is coming off of the solid cobalt and turning into cobalt ion. So I can show the motion of those ions. I can show the motion of the potassium. Which direction will the potassium move? It's going to move towards the cathode because remember, we are losing positive charges as they turn into neutral. So the potassium is going to move out here. The nitrate is going to move over here to help balance the charge of these extra 2 pluses. How about this nitrate here? Where does this nitrate go? This nitrate can actually start to migrate up through the salt bridge. Yeah? And you'll actually have cobalt start to migrate up through the salt bridge as well. Yeah? It takes a long time for the cobalt to make it over all the way over to the gold half cell and vice versa. Okay? And let's see. So what's going to happen is the cathode will always gain mass, and the anode will always lose mass. And I like to think of it as if you have a cat and you just leave out lots of food for the cat, what will happen to the cat? The cat will get fat, right? So the cathode gains mass, okay? Which direction do anions always move? Anions always move to the anode. That's literally why it's called the anode. And cations always move to the cathode. We will talk more about the voltages tomorrow, okay, because we have I think no minutes left. So we will talk about voltages tomorrow. But yes, at equilibrium, the voltage is always 0 because if it's at equilibrium, electrons don't want to flow anywhere, right? The amount that would leave, that would come off, would be the same as the amount that go on. Okay, and we'll talk more about why that is tomorrow. Okay. So that's like a nice little summary of everything. But if you know one of these, you pretty much know all of them. Thank you. Yeah.